Welcome to our channel. Today, we're diving into the mysteries of our closest celestial neighbor, the Moon. The Moon has fascinated humanity for millennia, serving as a muse for poets, a guide for navigators, and a challenge for scientists. Its silvery glow has inspired countless myths and legends, but beyond its beauty lies a world of scientific wonders waiting to be explored. In this video, we'll uncover 10 astonishing facts about the Moon that you probably didn't know. From its slow drift away from Earth to the presence of moonquakes, each fact reveals a new layer of complexity about this celestial body. So, buckle up as we embark on this lunar journey. Ready to be amazed? Let's get started. Did you know that the Moon is slowly drifting away from Earth? That's right, our celestial neighbor is moving about 3.8 centimeters away from us each year. This movement is due to the gravitational interactions between the Earth and the Moon, specifically the tidal forces. As the Moon orbits Earth, it raises tides in our oceans. These tides create friction that gradually slows down Earth's rotation while pushing the Moon slightly away. Over millions of years, this gradual separation will affect the length of our days. In fact, if we look far enough into the future, days on Earth will be longer than they are now. Additionally, the dynamics of solar and lunar eclipses will change, as the apparent size of the Moon in our sky will decrease. This drift also offers clues about the history of our Earth-Moon system, helping scientists understand the evolution of both bodies. It's a slow dance, but one with profound implications for our planet's future. You might think that quakes are exclusive to Earth, but the Moon experiences them too. Known as moonquakes, these seismic activities were first discovered by the seismometers left behind by the Apollo missions. Unlike earthquakes, which are primarily caused by tectonic plate movements, moonquakes have different origins. Some moonquakes are caused by the gravitational pull from Earth, while others result from thermal expansion as the Moon's surface heats up and cools down. There are also shallow moonquakes that can be quite powerful, lasting for up to 10 minutes. Understanding moonquakes is crucial for future lunar missions. Moonquakes also provide valuable data about the Moon's interior, revealing information about its composition and geological history. Unlike Earth, the Moon has a very thin atmosphere known as an exosphere. This exosphere is so tenuous that it's almost a vacuum composed of sparse particles that barely interact with each other. The primary constituents of the Moon's exosphere include helium, neon, and hydrogen, along with traces of other elements. One of the reasons for this thin atmosphere is the Moon's weak gravity, which is unable to hold on to heavier gases. Solar wind and micrometeorite impacts constantly strip away particles from the exosphere, making it a dynamic but fragile environment. The thin atmosphere also means that the surface of the Moon is exposed to harsh solar radiation and cosmic rays. Despite its thinness, the exosphere plays a crucial role in the Moon's interaction with its surroundings, including the Earth and the Sun. One of the most intriguing theories about the Moon's origin is the giant impact hypothesis. According to this theory, the Moon was formed from the debris left over after a colossal collision between the early Earth and a Mars-sized body named Theia. This cataclysmic event occurred about 4.5 billion years ago, shortly after the formation of the solar system. The impact was so powerful that it ejected a significant amount of material into orbit around the Earth. Over time, this debris coalesced to form the Moon. This hypothesis is supported by the similarities in the composition of Earth and Moon rocks, which suggest a common origin. Understanding the Moon's formation provides insights into the early history of our solar system. The giant impact hypothesis is a reminder of the violent events that can occur in the cosmos, events that have far-reaching consequences for the planets and moons we see today. For a long time, scientists believed the Moon was completely dry. However, recent discoveries have revealed that there is water on the Moon, particularly in the form of ice. This water ice is found in permanently shadowed craters at the lunar poles, where temperatures are so cold that the ice remains stable. The discovery of water on the Moon is significant for several reasons. Firstly, it provides clues about the history of water in our solar system, offering insights into how water was delivered to Earth. Secondly, water is a critical resource for future lunar missions. It can be used for drinking, growing food, and even generating oxygen and hydrogen for fuel. The presence of water ice also makes the Moon a more viable location for a long-term human presence. A common misconception is that the moon has a dark side that never sees sunlight. In reality, the moon is tidally locked to Earth, meaning the same side always faces us. This is why we never see the far side of the moon from Earth. However, both sides of the moon experience day and night cycles. Tidal locking occurs because the moon's rotation period matches its orbital period around Earth. The far side of the moon, often mistakenly called the dark side, receives just as much sunlight as the near side. The only difference is that we can't see it from our vantage point on Earth. Understanding tidal locking helps scientists study other celestial bodies that exhibit similar behavior. The far side of the moon has its own unique features and mysteries, making it a fascinating area for exploration and study. The gravitational pull of the moon has a significant impact on Earth's tides. The moon's gravity causes the water in our oceans to bulge out in the direction of the moon, creating high tides. As Earth rotates, different areas experience these bulges, leading to the regular rise and fall of sea levels that we call tides. The tidal forces exerted by the moon also affect Earth's rotation. The friction between the ocean tides and the Earth's surface slows down our planet's rotation over time. This gradual deceleration lengthens the days by about 1.7 milliseconds per century. The interplay between the Earth and Moon's gravitational forces is a complex and fascinating dance. The Moon's impact on our planet's tides is a testament to the interconnectedness of celestial bodies and their profound effects on each other. The Moon experiences extreme temperature variations on its surface, ranging from scorching heat to freezing cold. During the lunar day, temperatures can soar up to 127 degrees Celsius or 261 degrees Fahrenheit. In contrast, during the lunar night, temperatures can plummet to minus 173 degrees Celsius or minus 279 degrees Fahrenheit. These extreme temperatures pose significant challenges for lunar missions. Any equipment or habitats must be designed to withstand the wide temperature fluctuations. Understanding the moon's temperature variations is crucial for planning future missions. The harsh lunar environment requires innovative solutions to ensure the safety and success of any mission to the moon. The moon has been visited by 12 astronauts, all of whom were part of NASA's Apollo program. The first manned mission to land on the moon was Apollo 11 in 1969, with astronauts Neil Armstrong and Buzz Aldrin making history as the first humans to walk on the lunar surface. Michael Collins, the third member of the mission, orbited the moon in the command module. Subsequent missions, including Apollo 12, 14, 15, 16, and 17, continued to explore different regions of the moon. Each mission brought back valuable scientific data and samples, contributing to our understanding of the moon's geology and history. The last manned mission to the moon was Apollo 17 in 1972, with astronauts Eugene Cernan and Harrison Schmitt being the last humans to walk on the lunar surface. The achievements of the Apollo missions remain a testament to human ingenuity and the spirit of exploration. They paved the way for future lunar missions and inspired generations of scientists, engineers, and space enthusiasts. The moon has inspired countless myths and legends across different cultures throughout history. In ancient Greece, the moon was personified as Selene, the goddess of the moon, who rode across the night sky in a chariot. In Chinese mythology, the moon is home to Chang'e, the moon goddess, and her companion, the jade rabbit. In many cultures, the phases of the moon were used to mark time and guide agricultural practices. The full moon and new moon were often associated with rituals and ceremonies. The moon's influence on human culture is evident in literature, art, and folklore, reflecting its enduring presence in our lives. These myths and legends highlight the universal fascination with the moon and its impact on human imagination. Thanks for watching. If you enjoyed learning about the moon, don't forget to like, subscribe, and hit the bell icon for more fascinating space facts. The moon is more than just a celestial body in the night sky. It's a source of endless fascination and scientific inquiry. From its slow drift away from Earth to the presence of water ice, each fact we've explored today reveals a new aspect of its complex nature. We hope this video has deepened your appreciation for the moon and its many mysteries. So keep looking up and stay curious. Don't forget to share this video with your friends and family who might be interested in learning more about our closest celestial neighbor. Until next time, keep exploring the wonders of the cosmos.